Okay, I'm going to make this into a movie because I suspect that you will eventually need to know this stuff, even if it's too early for you to do it now. So in the Jose 2008 paper, they have a list of everything that they detected, and it comes out to be like 8,000 sources. And I noticed when I was trying to merge in that data with the rest of the data that there are some strange systematic position offsets. So I'm going to try to document how I figured this out and what I'm doing about it. So what we're looking at right now is a histogram, that is a count of the number of stars. And this unlabeled x-axis is the distance from the nearest neighbor star in arcseconds, and this is the number of stars. So in other words, what this histogram is telling me is that there is a pretty good number, 10, 20, 30, 40, 50-ish stars that have identically the same coordinates, or at least identically the same to within a quarter of an arcsecond, because that's 2 arcseconds, that's 1. And I was asking it to bin on half arcsecond intervals. So that tells me that there's at least 50 or so duplicates in this list. And then everything else is an arcsecond and a half, or mostly 2 arcseconds and longer away. So that means, this is telling me that they believe their positional accuracy is good to 2 arcseconds or better, but they did manage to leave 50 or so duplicates in the list. So the first thing I did was I went through, having calculated this distance, I went through, and then for each one of these with duplicate coordinates, I took out the duplicate and made a note, changed the name of the first source to be the first original name plus the duplicate name, so that we could keep track of the things that I merged. Now, the next thing is to try to get to try to see if the positional accuracy of 2 arcseconds is really what I'm expecting to get. So let me change what I'm sharing so that you can see what I'm doing. Okay, I'm gonna do this again. So on the front URSA page, there's a catalogs page, and the Jose 2008 paper is supposed to be linked back originally to 2MASS kinds of observations. So I'm going to choose 2MASS as the catalog that is truth, because that coordinate system is really reliable and good all over the sky. So I'm going to go pick that. I'm going to pick this. And then what I'm going to do, did I lose the window? Yes, I might have lost the window. Okay, let me make a new one. So there's a really, really, really helpful thing called the URSA table validator. And you can ask it to you can create offline a catalog that is kind of sort of a IPAC table, and then upload it to the table validator, and it will go and check to make sure that the formatting is right. So mine already is, because I've already done this, but you can go through the list and you can see, here's an example of one. 251 is the one that I took as the name of the source, and 252 was its duplicate that was lurking in the list. So here I have a catalog that's URSA compliant, that's got the name of the source and then the RA index. So I'm going to go back over to the catalog search tool where I picked point source catalog from 2MASS. I'm going to tell it I want a multi-object search. So I'm going to go get that catalog that is IPAC table compliant. I'm going to ask it to give me a one-to-one match. So what that means is, for every input line, give me one and only one line in the result that matches by position my catalog to 2MASS catalog to within 10 arcseconds. It takes the closest one within 10 arcseconds. So it's going to go do that, and then it's going to come back with, okay, so there's 7901 sources in the list. And it comes up with, that's interesting, it's got more than one catalog overlaid. Oh no, I see. Okay, so it's got the catalog overlaid on the image here, and then it's given us a plot here that's RA index. Now this is the search results, right? So it went through and it said, okay, for the first row in the catalog, the nearest match I could find was 1.05 arcseconds away. The name that you gave me was this, the position you gave me was this and this. This is the match that I found in the 2MASS catalog. So I can change what's plotted here. You can see that it's plotted RA and DEC by default, and it's got this region of higher source density here. That's because of the approach that Jose et al. Took in the paper. So they legitimately do have more sources in the middle. But that's neither here nor there. This is what the point is. This is kind of what I'm expecting. But let's change what's plotted. I'm going to leave the x-axis to be RA, and then for the y-axis, I'm going to ask it to plot dist x. So that is the distance to the nearest neighbor. Now, what I'm expecting to see is a bunch of matches within a certain distance. In other words, they think their positional accuracy is good to 2 arcseconds. So I'm expecting to see some scatter around the 2 arcseconds, but I'm expecting that it's gonna line up. I'm expecting that there will be a steep fall off of matches past 2 or maybe 3, maybe 5 arcseconds. But when we do this to the plot, look at this. So this is, because there's so many points, it's bin them up. So there's the distance as a function of RA. So there's a clump in here near the middle of the region that they cover that has really good positional accuracy, right? There's a lot of points in each one of these bins. You can see there's 20 or so if I put my mouse over it. There's 12 points in that bin, right? There's, there's other, yeah. So there's lots of highly accurate things within 2 arcseconds. But look, there's this structure, right? And there's like nothing here, and then there's this big thing up here. So what this is telling me is that their positional accuracy is actually pretty poor. And if I make a similar plot against DEC, I see similar structures. So that is telling me that their astrometric accuracy is irregular and varies over the field of view. So the next thing I want to do is try to figure out if I can understand those systematics. So let me start this again so that you can see what I'm doing. I'm going to tell it initially, please, actually, let me go back up here. I already, let's save this. Let's save this to disk. Okay, so that is now going to save it to my local disk with all of these columns in 100% IPAC table compliant format. So I'm going to go over to Ursa Viewer and I'm going to say, I would like to load the catalog I just saved. So there's the catalog I just saved. So you see it's got the row number, the distance to the match, the position angle of the match. That's going to be important in a second. And then all the other columns that it gave us back in the previous search. And it overlaid the catalog here on a HIPS image because this is a relatively large chunk of sky. And so by default, the tool picks a HIPS image because HIPS images are better than FITS, especially using 2mass for large chunks of sky. But I'm not ready to go on yet. I'm going to go to the catalogs and I'm going to say, I want you to also load in the original list of positions that I gave it. So now I have 2 catalogs overlaid here. I've got the results of the one-to-one matching, and I've got the thing that I asked it to search on for the one-to-one matching. So I'm going to go in this image here, I'm going to go to the layers, and I'm going to change, this is the second one, this is the one I just loaded. So I'm going to change the symbol to be, let's say, an X, and I'm going to make it big so that I can see it easily. And then the original, no, the matches is the red, okay? So let's go over here, and I'm gonna click on the top to sort this by distance. So all the nulls are things that it didn't find a match for within 10 arcseconds. But if I click it again, it sorts in the other direction. So there's the 9 arcseconds. Let's do a filter on this. Let's say I want only the ones that have a distance greater than 5. No, that's not what I want. Stop. All right, I gotta do it again. Sorry. I screwed up. All right, Ursa Viewer, let's load in the catalog, which is the results of the Gator one-to-one map, one-to-one searching. And then I'm gonna also load in the original table from Jose. Okay, and so now I got to change the overlays so that the table from Jose is a large X, and the table with the Gator results, the catalog search results, are in red. Okay, so now go back to this, sort by distance so that the big numbers are at the top. And because I really do think 10 arc seconds is just too big, let's filter this down so that we only have distances less than 5. Okay, and now I'm going to change, because this is big and I have to keep zooming, and it's, you know, it's a little annoying because I need to zoom in closer to see what I need to see. So I'm going to click on fits to force it to load a fits rather than a hips image. And I'm going to zoom in. So this target should be the one that is highlighted. Let's see if I can make it load again. Okay, so now it should be in the middle. It should, but it's not. Okay, so which one is this target? Okay, I'm not sure which one that is that target, but let's look and see. So the red is the match that it found within 5 arc seconds, and the green is the original catalog from Jose. Look, do you see any patterns here? Because I sure do. Here the red is to the lower right of the green. Here the red is to the lower right of the green. Here the red is to the lower right of the green. You see that pattern in a lot of places. Here, the true match, just given all these patterns, is probably that guy. But that guy didn't get grabbed by the automatic one-to-one searching because it was too far away. It found a match probably with one of these other sources. So in this part of this image, there is very, very clearly a systematic problem with the coordinates provided by Jose. And you can see this also here. So the distance I've sorted so that we've got all the 4.9-ish ones here. But look at the position angle. For all of the first several that are on the screen here, it's all like 115, 117, 119 degrees position angle. So in this part of this field, there is a systematic offset that is 5 arc seconds with the position angle, which is degrees east of north, and minus would be west. So all of this offset is real. Like the positions provided by Jose are not right. And I need to correct them by this same amount to match. Now, what's worrisome is stuff like this, where it doesn't seem to have found a match in 2mas, but this green X clearly needs to be matched to that position in order to find the counterpart. So that's a problem. Like this one, I don't even know why that bright one isn't in 2mas. I don't understand why it didn't find that match. Maybe it's just above 5 arc seconds. I wonder. Let's see if I can, if this is going to change. Yeah, it's going to change. 2128 was the row we had been on. Okay, so let's force it to do fits again and zoom in. This one really should be in the middle. Crap. Okay, so there it is. So let's see, did it find the friend? Yes, yes it did. It did find a match. So yeah, so this is a problem, right? Because we have to correct the Jose coordinates in order to find their counterparts. And the Jose coordinates are not always in the same direction, because you can see here there's a whole bunch that are more than 5 arc seconds off, right? And then down here, I mean, there's a whole lot more that match really well. So this is a problem, and we're going to have to figure out how to correct the Jose coordinates to make the match. If I zoom in, I bet we can see. Yeah, so here there's a different systematic. The green crosses are down and to the right of the red boxes. And if I go to another part of the plot, another part of the field of view, I bet we'll see something different systematics. Let's go down here. Yeah, so here the positions are doing better, but now the X's are pretty much straight to the left of the boxes. So there's all sorts of interesting systematic positional offsets here that we're going to have to try to sort out. And this is going to be complicated by the fact that not all of the Jose stars have counterparts in 2mas. Like this one, the position, the star it's trying to match is almost certainly that faint little blip right there. But that faint little blip isn't being returned by the 2mas match. So yeah, so this is not going to be something that we can easily do automatically, although I'm going to try to figure out a way because I don't want to do 7,000 sources by hand. But now at least you know the thought process and what tools I was using.